Yes, hi, this is George Zarakis again, and today I would like to discuss how to solve problems in Kirchhoff's laws. What's the brief theory that you need here? You need the two laws. So the first law has to do with current uh, that comes and leaves a junction of a circuit. So the sum of the current that is going in is equal with the sum of the currents that are going out of the junction. And the second law has to do with potential difference, and the sum of potential difference across a loop has to be equal with zero. Let me do an example so you can better understand what I said. So we have this circuit here. This battery here is 70 volts. This is 80 volts, and we have another one here which is 50 volts. And we have this resistor here is 2 ohm, this resistor here is 3 ohm, and this resistor here it's 4 ohm. So let's start from the last one, which has to do with the currents. So if we take this junction here, okay, we have that I1. First of all, let me draw the currents that are going through the different parts of this circuit. So this is I1, and when it comes here, it spreads in I2 and in I3. So now we have, if we take this junction here, we have that I1 has to be equal with I2 plus I3. That's the first law of Kirchhoff that has to do with current. Now, what we do here, in order to apply the second law of Kirchhoff, which has to do with potential difference, we have to take the loops. So here we have one loop, which is this here, and another loop, which is this here. Since this is bigger than this, we should go and say that 70 minus 50 is equal with 2I1, plus 3I2. And 70 minus 50 is 20, so all this is 20. And now if we take the second loop, we have, again, because this is bigger than this, we have that 80 minus 50 is equal with 4I3. Okay, because the I3 will go through this here, minus, because we assume that this is the positive direction. So this here, because it's in the opposite of the direction that we assume that is positive, this here will be 3I2, because the I2 actually is in this direction. So that's it. And now you just have to solve this system of three equations with three unknowns in order to find what you're looking to find. So what I'm doing, I just substitute whatever I1 here equal with I2 plus I3, so that will give me 2I2 plus I3 plus 3I2 is equal with 20. And if I do here the multiplication, it will be equal with 2I2 plus 2I3 plus 3I2 is equal with 20. So 3 plus 2 is 5. 5I2 plus 2I3 is equal with 20. Now I take this equation here and I multiply it by negative 2, so that will be minus 2 times 5 is minus 10 I2, minus 2 times 2 is minus 4 I3 is equal with minus 2 times 20 is minus 40. And I take also this equation here, so which is minus 3i2 plus 4i3 is equal with 30. So if I add these two equations, the i3's, they cancel each other. So I have that minus 13i2 is equal with minus 40. So i2 is equal with 40 over 13. So this is equal with approximately 3 ohm. So now I take these 3 and I plug it here. So I have minus 3 times 3 plus 4 times i3 is equal with 30. So and if I solve this, it will give me that i2 is equal with 39 over 4, which is approximately 10. And now I take these two and I put it in this equation here, and I have that I1 is equal with 10 plus 3, so that's 13 ohm. I mean, the question here was, in case I missed it, the question here was to find the currents that are going through the different parts of the circuit. I mean, I would like to explain a little bit better on how to do these problems. The second law of Kirchhoff's, it's actually the Ohm's law. Just you have to take, you see which one is bigger, and if there are more than one batteries, you take the one which is bigger and you consider this to be the positive direction. And so that's exactly what I did here. So that was the example, that was about Kirchhoff's laws. Thank you for taking the time to view this video, and I hope you find it useful, and bye for now.